Apologies. All right, so one of my favorite lectures. Ta-da! Games. Who wants to develop games when you grow up? Really? You want to make games? Okay, okay. Do you know famous game brands? Sega, okay. My friend works at Sega. Yeah. You want? Toshi Kiyomiya. It's in LinkedIn. Look it up. Toshi. Sega was bought by a pachinko brand because they didn't make enough money. What else? Capcom. My friend used to work at Capcom, translating games from Japanese to Spanish. They pay very bad. They are in Osaka. Yes. Ubisoft. Are they French, these guys? I don't remember now. What else? Square Enix. Why are they famous? Why is Square Enix famous? Which game? The hair? They have a museum in Tokyo. It's very nice. You like games? Rockstar? I don't know this one.
GTA and Red Dead.
Okay. Okay, I want you to forget all these brand names. If you want to get into gaming now, you should go in through mobile games because they are easy to develop, right? It's very expensive to develop a PlayStation game. I mean, it was possible 20 years ago, but not now. Do you get it? Yes? If you're interested, there's a really good podcast about Activision. And it involves Steve Jobs and some jokes. And it's hilarious. I will post it later. It will make you laugh a lot. It's about a student who started a game development company called Activision. If you listen to it, I will give you a bonus point for the weekend. You got it? It's hilarious. Okay, second question is, why would you like to develop games? Who said it's for the money? Okay, it's good. Somebody else? Other reasons?
Because we love the games and we like to participate in it.
Which is bigger than Hollywood, right? Awesome, very interesting. Yeah, yeah, good. When I was a student in Tokyo, one weekend, 3 weekends, I went to a company which was nearby. They make a game called Sengokushi, which is about samurais fighting with armies and stuff like that. And my job was to play the Spanish version of the game and tell them problems with the translation. And it was great because the day I went there, it happened they sold the millionth copy of that game. So there was a sushi party. It was great. And the second thing was that the employees would come dressed in cosplay to the office. So I told my manager, what's that? It's cosplay. He said, it's okay, it's a game company, it's fine. So that company employed lots of women, because they said that female was the biggest customer of the company. But most employees were males, so they could not design very good games for females if all the employees are males, right? So they made an effort to employ more women, and they wanted to develop games for women. Games, because most games are for guys, basically. But if you look at the statistics, most players online are women. Did you know that? So there's kind of a mismatch. So it's a very good opportunity. But anyway, those games are very expensive to develop, but you can start, if you want to get into this industry, start for the new fields, which is mobile games, which is not new anymore. PC games is kind of very difficult to get in, right? Maybe it's easy now, I don't know. But mobile game, casual gaming, have you heard this word, casual gaming? Casual gaming. Casual gaming is not serious gaming. It's casual. It's for people that are bored and play 5 minutes and that's it. It's a big industry also. Okay, cool, excellent. So let's see a bit how animation, games, and computer graphics are related. This is a very good lecture from our friends from, I think this was Stanford. Right, so we will talk about these 5 things, 5 concepts only. How do you build a world in a game? The controls, the camera, AI, and navigation. Okay, so let's start. So how do you build this scenario? Which is the same question. How do you build the scenario of a movie? So most of the time you buy pre-made objects. You reuse it from your library. If you use engines like Unity is great. Why? What's your name? Shams? I knew it. Rim, did you use Unity before? And so what's good about it?
We already have the resources in the store.
Exactly. You have resources? There's a store now?
Yeah,
There's a store. Wow. So you can buy things. And there's wind, automatic wind in the world. So you don't have to program the wind. This is a huge. So you can focus on the productive stuff, right? So that's really good. So the background, the world sets the atmosphere of the game. This is really important. So you want to employ a good graphic artist to do this. Also, there's another important function of the world. It's to guide the player through the game. So how do you do that, right? So that's an interesting space. For example, here you have an example of Mario, right? And
this game in the Wii, right?
yes, correct. And so, how do you guide the player towards the playable areas without telling him, hey, there's nothing interesting here, don't go here, I didn't program anything here. The game is around. How do you tell him, right? So you can use what they call props. So props are things that help you give directions without being too obvious, without putting an arrow there like, this is the next step. I didn't program here. There's nothing here, don't go here. No, you cannot say that. Does that make sense? So do you see any props here, for example?
The road.
The road, very good. Who said the road? Shamsa. The road is a prop, right? Which would be what? This thing here, right? This, I think this is the road, yes? That's a very good one. Right, so yeah, so tools to build worlds, Unity terrain. Is this updated now? I think it changed. They still have this one? Yeah. Some people use Google SketchUp to build their own stuff and import it. Are you familiar with Google SketchUp? No? Google SketchUp is an online tool. It's called CAD, where you can build buildings. So you can have someone to build a building unit for your game, and then you can export the model and import it into the game. Yes? So Google SketchUp, very famous. I'm just going to show it in the screen. This is Google SketchUp, basically. It's a free tool by Google. So you can build this stuff, and it's free. It's awesome. Wonderful. For 2D, you have other stuff. I didn't want to change that. Okay. And for characters, how do you design a character? So there is special software for character design. One of them is called Lightwave Magic. So there's a special software just to make characters. For a few years, I'm not updated now, but when I was a student, for characters there was a popular one called Lightwave. And they used that for characters because it was good because something. Lightwave Magic. That's the one I was using. This one. Modeler. Last year, one of the students used Blender to build this nice character. So I think Blender is also a very good option. Wonderful. Mesh rigging. Anybody remembers what's rigging? It's when you put dots in your face. Yeah? Okay, so we just bought a very expensive tracking system in the lab. Maybe you saw it, some new cameras in the boy side. So you can go there and put your markers on and animate, do whatever you need to do, and then animate. Does that make sense? Did I show you the video where they... No, I didn't show it to you. I'm going to show you a very cool video. Yeah. I don't have it right now, but I'll send it to you later on Slack. It's a very cool video where there's an empty space and there's this guy with the markers and some fake guns, and they make a movie. They're shooting a movie. And you see, like, I don't know, it's just a table here and here and here, and the guys are like fighting, and then you see the movie and they are like in this castle, and it's really interesting how cheap they make a very good movie. So you might want to explore this option also, because we have the cameras here to do this kind of crazy stuff, okay? All right, cool. So mesh rigging, animation. There's a problem though. If your wall has too much detail, what will happen? Your game will slow down. Yes? So it's a problem. Right. So here's an interesting thing about composition. You will also see this a lot, POV, which means point of view. Yes? Point of view. This is the camera. So when you have a camera, you may see these lines. These lines help you kind of frame things. Usually interesting things are around here, not here, right? Yeah, so this kind of weird rule, but if you wanna, if the important thing in your action is happening somewhere in the camera, there is this rule that it should be here, 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 or here. It should not be in the middle exactly. It looks weird, I don't know why. Something to do with Zen or Feng Shui, I don't know what is it. Make sense? So that's one rule you can keep in mind. another very interesting trick to make your game flow is what they call leading lines. So let's see if I can. So for example, here, here for example, this like a role-playing game. So you have one character and you have to navigate through a world. So how do you tell the player that, hey, there is something interesting here without telling him so he feels he's exploring, right? So you can use light or what they call leading lines, like subliminally telling the player, this is the way. Does that make sense? Here the same, maybe the course of action is to walk this path, not jump here, right? So kind of telling without telling. So the player feels like he is exploring without being actually in a cage. Here the same, here the same. So these leading lines, you can use them in your games. Let's talk about the camera. We saw the camera. When you build an animation inside your world, you will have the camera somewhere. You have the world and then the camera, and you can move the camera, and that is also, the camera doesn't need to be static. The camera can follow the players or your characters. Yeah? Doesn't need to be static. In computer graphics, when Disney was working, the camera was fixed and he was moving the paper. But now you don't need to do that. You can move the camera. So you can fly with the camera. You can do lots of stuff. So don't be afraid to move the camera. We saw these angles, right? Yaw, pitch, roll. Rotation matrix. There is this thing that when you have this kind of degrees of freedom, there is a position where the angles lock and then your camera is locked. So you have to be careful with that. It happens to me many times. So, okay, cool. The camera has a direction vector, which is where is the camera pointing. Does that make sense? So if this is X, Y, and Z, can somebody tell me what is the camera vector here? X, Y, Z. Can somebody tell me what is the camera vector? What are the numbers of the camera vector? The camera has a vector which points where the camera points, yes? So if this camera is looking this direction, this is X, what would be the camera vector here? What do you think? 0, 1, 1, 1, 1, 1, 3, 3, 3, what? Anybody? No? So I have a camera here. So the camera vector is this vector, okay? So if the camera is looking down, the vector is looking down, okay? So if this is X and this is Y, what is the camera vector here? Okay, so it would be this, right? And what is this vector? Hmm? What is this vector? I don't know how much in this direction, but in this direction, 0, right? Something here, right? So the camera vector, we always, doesn't matter the magnitude, the length of the vector. What matters is the direction. So we don't care about the numbers. So you can say any number as long as this is the same direction. So in this case is, oh, very good. Thank you. Good point. -1, 0, right? What about this one? What's the camera? Yeah,
Negative
give me
one.
numbers. Give me numbers.
Negative 1, negative 1.
Yeah. Or -2, doesn't matter. What's the camera vector here? X, Y, Z.
It is something but 0.
It would be 1, 0, 0, right? Because it's pointing in the X. Yes? Yes? No? X, Y, Z, so it's only pointing here, so 1 and 0 and 0, right? Yes? If it's pointing up, what would it be? 0, 0, 1. Don't mix the order. Yeah? Very good. Right, there's another keyword you should know. It's called parallax. Do you know parallax? Have you seen this word before? Parallax. Your iPhone has a parallax option. It's silly.
Yeah, the camera.
The background, I think, has a parallax option. Like, I think. Yeah, like, I'm not sure now how it works. I deactivate it because it's so silly. But if you do like that, it parallax. That's called parallax. You got it? Do you know a student who became famous with parallax and the Nintendo Wii? His name is Johnny. Johnny. Do you know him? Johnny made this very cool video. Let's see. YouTube. Johnny. He made this when he was a student.
First, what do I mean by desktop computer display? Well, when you think about most computer screens, they're typically used to display a flat image, a little bit like the picture in the picture frame. Even if the picture is of something 3D, like a video game, the picture is still flat. So it doesn't change depending on what angle you view the screen in. A desktop VR display, however, is a little bit like taking the picture out of the picture frame and then just having it in the frame. Now the scene actually changes depending on what angle I view the screen in. So this essentially becomes a portal or a little window into another room. Now to do this, the computer needs to know the location of your head relative to the screen, and this is called head tracking. Now to perform head tracking, we're going to be using the Wii remote and the sensor bar. But we're actually...
How would you do head tracking? Very cheaply.
Head tracking.
Yeah, head tracking. So we track the position of the head, so the game can know where you're looking to fake that it's 3D, but it's not 3D, it's just a screen, right? How would you do it? Would you put a camera and look at the head? And
You put a tracker.
Glove that attention to some point. Actually, like that one.
let's see how Johnny did it.
We're actually going to be using them backwards. We're going to put the Wii remote next to the TV and actually move the sensor bar instead.
So do you remember the Wii remote?
Yeah.
The Wii remote, the Wii knows the direction of this guy, the vector. Same as the camera, right? How do they do it?
Depends on the sensor.
They have some infrared lights and markers. So there's some lights, beep, 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 and it kind of calculates. Does that make sense?
Instead, the Wii remote actually contains an infrared camera, and the sensor bar is simply two sources of infrared light. When the camera sees the two dots of light, it's going to give an approximate location of my head horizontally, vertically, and in distance from the screen.
Does that make sense? There's a camera here, so there's two dots of light. So if the two dots of light are close, it means that the bar is twisted, right? And so on. That's how they do it. Does it make sense? So, yeah, like look at the look at the board there, right? You know more or less the angle that is not flat to you, right? How do you know that? How do you know? Because you know it's a square. And this side is bigger than the other side. And you have experience, and you know.
It's a paradox actually in physics.
Huh?
It's a paradox in physics. We don't know why we can't detect the objects.
We know because you know it's flat.
Yeah.
You know it's flat. You assume it's flat, and then
We had experience, but then actually we don't know.
you don't know, and that's how they make these fake pictures where it looks like like a waterfall falling, and then you go there and it's just a painting, right? Okay, so that's the same. If you know that in reality it's a bar, and it's not appearing like the distance it should be, like it's too close, the two edges, then you know it's twisted somehow. So that's how they estimate the angle.
Okay, the tricky part is now we're going to have to find some way to mount the sensor bar onto our head. One common trick is to get a baseball cap and then mount the hardware to the cap. And this is definitely going to work, but it's a little bit goofy. So instead, some hardware stores sell these safety glasses with LEDs built in on the side meant to be used as headlamps. Now, if you replace the LEDs with infrared ones, you essentially get your head-mounted sensor bar and a nice sporty safety goggle form factor. Once we've created our head-mounted sensor bar and I've connected my Wii remote to my PC, we're ready to do some head tracking. Behind me is a demo program of a 3D room with some targets floating in it. Now, because the effect only works for the person wearing the sensor bar, I'm going to have to show you the effect through a moving camera. Now, to do this, I'm literally just going to hold the sensor bar at the base of the camera and move it around. Just a quick note, to power the sensor bar, I simply turn on my Wii after I've connected my Wii remote to my PC. First, I'm going to show you what it looks like without head tracking, which is what displays normally look like. You can see that although it's a picture of a 3D room, the image looks very two-dimensional and bound to the surface of the TV. Now, with head tracking turned on, the TV actually looks like the entrance to a real room.
Wow.
Just like in real life, by moving our head around, we can look behind objects.
How is this possible?
Really close,
Yeah, it looks 3D.
It looks so it's just an illusion in your head, right? You're used to when you see different dishes that if you move your head, they're going to move in a certain way, and we just simulate that very fast by changing millimeter by millimeter, second by millisecond, because we know your head position thanks to this thing, right? It's the same that the iPhone tries to do when you activate the parallax. They look at your, I don't know how you do it, but. Got it? Interesting. If you go to gaming conventions, you will see many people with these caps. As they use it, for example, in flight simulators. When you want to look through the window to the left and to see what's happening, so the game knows that you're looking to the left, and then it shows you. Or VR is another example to the limit. Yes? A problem with this is that our brains are really adept and we're very sensitive. So if you make a mistake, the brain thinks, this is fake, but it's not fake. What's going on? And we have headache. So some percentage of the population will have headache. Same as with the 3D TV. Yeah, same problem. Okay, cool. So this guy is Johnny, and he, with $500, he made this research project. It was great. This was 2008. He's working at Google now, doing other stuff. Okay, cool. So very interesting stuff. Awesome. Right, so let's see here. So that was parallax. Another way to do parallax, if you play Mario, the castle is moving at different speed from the, right? Or if you're driving in the highway, you see the trees moving faster than the dunes. So that's the same effect. So you can use it. It's a very cheap way to create this illusion of 3D. By the way, this kind of game is called platform games because there's a platform. Yes? Platform games. Okay, cool. Another way to put the camera is called top down. So this was very popular in the 70s because the computers didn't have a lot of memory. Remember, my MSX computer had 64 kilobytes. So you don't have a lot of memory to do parallax or anything. So it's just from the top, which is also a very interesting way to play. Yeah, they're very good. This is very good for role-playing or strategy, where you have to navigate something. Typical example, the tank battle, for example. It's great to play this way. See everything you need to. Right. Another interesting view that you have is called ISO. Do you know what it means, isometric? Are you familiar with views, isometric and stuff like that? No? Yes? Okay. So when you guys look at the world and you see the objects close, big, and the objects far away, smaller. Yes? Because the way your eye is constructed. Your eye has a hole in the middle, there's a lens, all the light from the world comes into the hole, and then it crosses and it projects in the retina. If you think about it, an object which is close to this hole will occupy more space. It appears bigger, that's why, that's it. An object which is far away, it occupies less space. Does it make sense? So we use this coincidence to estimate how far is an object. And we are very good at that. When you see things this way, remember the other day I drew something on the whiteboard and it was like lines and perspective, right? The way we see the world is called perspective because wherever you look in the infinite and there are straight buildings or objects, all the lines that are parallel will converge into that object. So right. That's very nice. But it's not very useful if you're an engineer. If you're an engineer and you want to show a building, they usually use not perspective, but isometric view. In isometric view, the objects far away are as big as the objects close by. And this means that all the dimensions here are called true magnitude. It means that even if some object is far away, what it measures is what it will measure the same close or far away. Does that make sense? And so look at these. The camera is pointing like 45 degrees down. Yes? So if you have the axis here, if you look at the angles of the camera, it's 45, 45, 45. So 1, 1, 1 or minus 1, 1 is minus 1. This is the typical view of called isometric. Okay? When the camera is like that, all the dimensions, all the lengths that you see, if they measure the same, in reality they represent the same distance. Yes? Isometric is great because if the character goes far away, you don't need to change the size. Right? So it's less computation. It simplifies lots of things. Yes? So many games use this view. Can you tell me any famous game that uses this view, isometric? No? Really? No? Nothing? No famous game? What about Clash of Clans? This is an example. If you see a normal building, you will see it like that. The things closer are bigger, and then if it's isometric view, it's like this. The problem with this one is if you move the camera, you will have to change. Like when I move, the table changes, right? In isometric, I just need to move the pixels, that's it. I don't need to change the perspective. So any famous game that uses isometric? Have you? Subway? Okay. What about Candy Crush? Do they use isometric, I think?
I know a game called
Fire Emblem. Fire Emblem. Fire Emblem.
That old one there. What game was it?
Fire Emblem. Here we coming. Let's see.
Not Game Boy.
Game Boy. Oh, I can see it here. This one, right? Yeah, this is isometric. Very good. Any other games? Isometric?
The Smurf.
The Smurfs. Yeah, probably isometric. Perfect for isometric. All of these games of warriors going to kill other warriors, and you see from far away, isometric. What about Fortnite? Is it isometric? No. Fortnite uses perspective, which is great, but it's expensive. But now it's fine. Okay? Many web-based games use isometric. There's even a library for JavaScript for isometric. So. Okay, one more. The other way to put the camera is this one, called first person. Right? So you are the player, and it's the most immersive thing that you can do. For the cameras, there's a thing called field of view. Do you know what's that? Yes? What is that? That what?
The vision.
What?
The
Yes.
range of view the player can.
The range? Yes. What is it?
The range of vision. It's 360.
Yeah. The width of view, right? So if you do this with your hands, do this with your hands, and then put it close to your eyes or farther away, right? So look at the edges of your fingers. When they are 70, it means the field of view is 70, right? When it's closer, it's wider, right? If it's next to your eye, it's 180. You see everything. But in this class, we will say, in the exam, you will say field of view. So wide or narrow? Narrow is like a telescope, like zoom, which is good for some things. And wide is good for other things. It gives you a lot of perspective, right? To see a lot of things at the same time, but with not a lot of detail. Narrow, you can zoom in something. So you can play with these to change how the game feels. Very good. So that's camera first. 70 to 110, these kind of games like shooter, stuff like that. Then you made it a bit wider, 90 to 130. Third person. So you are watching your friend playing, right? So you want a bit more width to see what's going on the side, right? Because you're farther away. Make sense? Right, cool. Another thing you should know about camera, we saw it in the Pixar documentary. It's called the smooth motion. So when in a typical game or animation, you will move the camera. So you will make a path for the camera, but you have to be careful to make it smooth. Does this make sense? And the camera, remember, is not, usually it doesn't move a lot like that, but it moves the direction. You will see a keyword called slurp. So slurp is a smooth path, but in angles for the camera. So it's the rotation matrix, how to make it smooth. Yes? So that's one thing you should see. And the other thing you should be careful is with motion sickness. What is that? if you move the camera a lot, well, or the people will not like it. So there's another problem with animation. It's called clipping. That's when you have your camera, you have your wall, and then you plan some movement for the camera, and you just go inside an object, which in reality you cannot. But then what? So you have to be careful with that, because it doesn't look very good. Yeah, and the other important effect you should know, it's motion blur. So in cinema, when a car goes fast in front of the camera, it blurs. In computer graphics, it doesn't blur. The computer can make it as fast as you want, but then it doesn't look realistic. So you can add this effect of blur when you want to convey that something is very fast. Doesn't that make sense? But you have to create it artificially. That's called motion blur. Remember the André movie in the Pixar? This the first animation they did with this the bee, the big bee.
Yeah.
So they were the first to implement motion blur to fake this effect of speed. Yeah, remember? So that's motion blur. Some people simulate shakes of the camera. There's an explosion. The camera will not shake. In reality, yes. So you want to shake the camera out artificially sometimes. Film grain. Like, for example, if you are inside a car that is crashing in your animation, the camera will be perfectly smooth while you're crashing. It doesn't make sense, right? So you want to add some shakiness also there. Yeah. Controls. This is the periodic table of controls. Controls affect how you play the game a lot. So. Right. Yeah, when you are on mobile, remember when the iPad came out and you could tilt the iPad to move the players and stuff like that? So that was a big innovation that it kind of, nobody uses it anymore. People went back to normal controls. It was like a fad. It didn't catch on. Some control tips. There's this slide is important, so usually it's in the exam. So there's two laws that you should know. Probably you know them. Do you know these laws? No. Fitts law and Hicks law. Maybe from who did user experience design here, or human-computer interaction? You did it?
Yeah.
Okay, did you see these laws? No. Okay. So why are some interfaces easy to use and why are some not easy to use? So here you have some explanation. One is Fitts law. Fitts law says, who wants to read this one? Nobody? Volunteer? Yeah, you. You move your hand, so you volunteer. Fitts law.
Time required to rapidly move to a target area is a function of the distance to the target and the size of the target.
1954. Fitts law. You get it? The time required to rapidly move to a target area is function of the distance to the target and? Okay, great. So why the blackboard is so frustrating? Because this is the mouse and this is your finger and this is the screen and these little areas to go to the next question, I think, right?
Yeah. Especially on iPad.
So you have to move like 900 pixels usually to go to the next question. And you have to hit like a button which is 20 by 20 pixels. Right? So it takes more time than if it was a bigger button. And it takes more time than if the button was here. Does it make sense? So if you want to annoy the user or make the task difficult, what do? You can reduce the size of the target and the distance. You have to, click here for the next question, but click here to answer. It could not be designed worse. But sometimes you can use it like, oh, I don't want the users to accidentally go to the next question, so I'm going to put it far away. So you can use it as a design property. Does it make sense? That's Fitz's law. What's the other one? Hicks' law. Who wants to read this one? Hulut. Yeah. Yeah. Logarithmically. What does that mean? Logarithmically. I'm going to chart here logarithmic. Logarithmic is, this is x, and this is the log of x. So logarithmic means something like that. So if I have one option, I will take, and I take 1 second. If I increase the options to 2, I will take 1 point. Can somebody Google logarithm of 2? Tell me the logarithm of 2. What? Log of number 2. How much is it? 0.3. And log of 4?
0.6.
I knew it because there's this property, right? That the log of a squared is 2 log of a, right? So if this one's 0.3, log of 4 is 0.2, 0.6. Got it? This means that if you have a test, if I give you a test, true or false, or 4 options, you're going to take double time to hit. Does this make sense? And ignoring the complexity. And if you have a game and you have, the user has to hit 2 buttons or 4 buttons, the time he will need to do this, it will be double. So you can use this to design your animation games, stuff like that. So these 2 laws. And these 2 laws are the explanation of why some interfaces are easier or harder to use most of the time. Does it make sense? AI, let's talk about AI. Haha, my favorite topic. AI. So is anybody familiar with AI in video games or graphics? Yes? How is AI used in the games today?
Secondary character.
Yes?
To
Secondary character?
respond with the
Oh, you were talking. I thought you were talking. Sorry. Yes. Name?
Shama.
Shama.
Like you play with the main character, secondary character responds to whatever.
Yeah, exactly. Yeah.
Playing on its own.
That's like that. I told you the story when I was in a party one day, and the Square Enix party, and one guy, I asked him, what's your job? And he said, I am the programmer of the AI. AI of what? In the Solid Metal Gear, I programmed the AI of the guy, of the soldiers that try to catch you. It's like, wow, that's so cool. Okay. So if you took AI class, you know, there are many ways to give AI to some characters, rules, simple rules, decision trees, and more complex stuff. Does it make sense? Are you familiar with finite state machines? finished state machine is, for example, your AI character is in the state of waiting for you to enter the scene. So it's just walking around. Once you enter the scene, it will enter in alert mode. So he will start pretending to watch for you. So in this, if you have states and you define a behavior for each state, it looks like really smart. Does that make sense? However, sometimes just giving random behavior, and this is true, my colleague made this game called GoBattle.io. It's a platform game, and I'm going to show it to you right now. GoBattle.io. GoBattle.io. And this is so funny. Come on, internet speed, you can do it. It will not work. No. You can find it in through your computers, probably faster. GoBattle.io, images. Oh, wow, it's so fast that I have motion sickness. Battle. Right. Here you have an example. What kind of game is this? What kind of perspective they use? 2D, very good. And it's a platform game, right? So there are characters here which are AI, right? And what do you think about the behavior of these AI characters? Would you say it's there's a lot of AI here, or interesting
Only one action.
Okay, these dragons doesn't move so much. Yeah, right. These dragons doesn't see. What about this one? Let's see what they do. All right, so in this game you have to explore, and there are robots. This is a robot. What do you think about the AI of these robots?
Only one action, or like two.
Very good, very good. Because my friend programmed these robots to do random, like move left, move right, shoot randomly. And it's funny because people said, "Oh my God, the AI is so good of this character." It was random. So that was really funny. The other funny thing they discovered was that so there's humans playing and robots playing, right? So that if there is only one human in the game, it doesn't feel alone. And the other thing is that humans are so bad at playing this game that a robot which has random movements would sometimes be the top scorer. So yeah, so AI has a lot of potential, I think. Questions? Okay, cool. So states can help you to make the AI a bit more sophisticated. Behavior 3, these are things that you can see in AI, but okay, and finally navigation. So when you have other characters navigating the game has obstacles, so you will have to do what's called path planning. So this is an example of a straightforward navigation from A to B, but usually games have like obstacles in it, and so you don't want to program every AI, every point where it goes, every waypoint, so you will have to do some navigation AI to simplify your task. So one way to do that is to use grid map, and there are algorithms to optimize this that you will see in the AI class, okay? That's, you know. So this is another example, and so on. Cool, excellent. So that's all about very simple game mechanics. Yeah, the most important part of this lecture is the camera stuff and the perspective stuff. That's all. Questions? Okay, so we have 5 minutes. How is your storyboarding going? Did you prototype? Did you prototype? Do you prototype more? Do you want to show something? Do you have something to show? No? What about you, girls? How about you? Is this your new storyboard? Okay, let's see it. Hold on, I'll bring my laptop. Hold on. Okay, show me. All right. Animate the voices. Hello, welcome to my animation. Okay, next. Okay, so far, yeah, plants. Plant. Oh, it's throwing plants into the well. Plants, plants, gym, 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 work, work, work. Yes, I got it. And then dynamite, dynamite, boom. Anticipation.
It's like timing.
Anticipation. 2 seconds. Plans. Plans.
Then I didn't continue, but then they call about this and they come back to it. It does not matter if you found them, they will come back to it.
Sounds pretty interesting.
I showed them to a couple of people.
And what did they say?
They think it was funny.
I think the key here is the expression of the guy, how it changes, right? And you are expecting that it will change, so it builds anticipation. It has a lot of potential. How are you gonna make? Are you gonna make the character remarkable and stuff like that, or how do you plan to do that?
We don't know yet.
Is it a pissed off character or a good girl character, and suddenly it turns dark?
You said if we used a new character, we have to introduce the character.
Right. Oh, I get it. I get it. Okay. But you could use a new character which is funny by itself, but simple.
Can you like build on this character?
You had a very cool character the other day, right? So you could use it.
Because it was the theme. The theme was
I think it's great.
but the theme was like he was robbing someone.
Don't feel afraid
But
to.
maybe without the mask.
Yeah.
Yeah.
You have very good drawing skills, so fantastic.
We stopped like maybe.
So yeah, good. What about the well? Is it gonna be humanized? Will it be like
Yeah.
happy to eat things and then boom? or
We thought when we bomb, if the bomb goes off, this character is like he will jump off the road and
Like-
his head will fall.
No. No, that's way exaggerating.
Like his head would be out.
But he will be affected by the explosion that he will
okay. Good. What's the next step then?
And then should we say back huh?
We don't know if he will do that.
Here yeah, when everything falls on him, then yeah, this camera will be focused on his face,
Yeah.
and he's trying to relief, and then he will scream maybe or something.
Awesome. Will this character be wear an abaya or no? Why not? Do you think people will be more related to it if you wear an abaya?
No, I guess.
Because we want it to be like more
Cartoon?
Cartoonish?
cartoonish na
Not
not specific to our culture.
Okay, hold on. Okay, bam, 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 and then would it build anticipation if the well starts feeling bad, like
give it character.
boom? Okay, good. I think there's a lot of potential here. And what's the moral of the story?
I don't like
Don't throw everything.
Don't escape your
Don't throw dynamite.
It's your
responsibility.
fate, you'll do these things.
Face your responsibility.
Very good.